Okay, guys. So I want to go ahead and start with exploration 1. Well, I guess it's actually exploration 2. I must have deleted exploration 1. I want to actually start with this. I want you guys to do A. So it tells you to use 2 different colors. So you are more than welcome, when you are graphing those, you are more than welcome to turn them into slope-intercept and get y by itself if you want to do it that way. Or you can do the cover-up method and do it that way. Just make sure you remember, if you do the cover-up method and keep it in standard form, you need to test with an ordered pair to see where you shade. If you turn it into slope-intercept and you get y by itself, if y is bigger, you're going up. If y is less, you're going down. Okay? So you just have to make sure you pay attention to which way you're shading based on which way you graphed. Okay? Then once you do that, then go ahead and answer parts B, C, and D together with your groups. Okay? All right, go ahead. Okay, so inequality 1. I am guessing that most of you like to turn these in to slope-intercept, so that's what I'm going to do. So for inequality 1, I would have to subtract 2x from both sides. So I end up with, whoa, too much. Y is less than or equal to 4 minus 2x. Okay, so let's go ahead and graph that. So 4 on the y-axis, slope of negative 2 is down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Is this going to be a dotted or a solid line? Based on what we learned yesterday. Dotted or solid line? Cuckoo! Good morning. What? Solid line, because it's equal. Okay, so there's my line. And then y is less than, so I'm going to shade down below. So there's inequality number 1. Now let's do inequality number 2 with a different color. So I subtract 2x from both sides. Okay, so I have negative y is less than or equal to negative 2x. I have to get y all by itself, so I divide by negative 1. Dividing or multiplying by negative makes me flip my inequality sign, so I end up with y is greater than or equal to 2x. Okay, so I have my y-intercept is 0. It's going to cross right at the origin. My slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, down 2 left 1, down 2 left 1, down 2 left 1. Is this going to be a solid or a dotted line? Solid. Okay, and then it says y is greater, so I'm going to shade above the blue line. Alright, so now let's talk about this. Okay? Now let's talk about this. So we have a couple of different questions. So it says, describe each of the shaded regions from the graph. What does the unshaded region represent? So let's go piece by piece and let's talk about each one. Okay? So everybody look up at my screen. What does this unshaded region mean? What ordered pairs lie in this unshaded region? I guess let me ask it this way. Do the ordered pairs in this shaded region satisfy inequality 1, the red inequality? Do the ordered pairs in this unshaded region satisfy the inequalities from the red inequality? Or the ordered pairs from the red inequality? No. The unshaded region means it would not satisfy the red inequality. Does it satisfy the blue inequality? No, because it's not shaded, right? So this unshaded region would be ordered pairs that do not satisfy either one of those inequalities. Okay? So we have to know what is satisfying what. That's why we talked about earlier when we were going over prep, we talked about the shaded region is what satisfies that inequality, right? So the unshaded region would be, that does not satisfy either one, okay? Let's talk about this little top blue triangle, okay? This little top blue triangle right here, does it satisfy the red inequality? No, because it's not shaded red right here. Does it satisfy the blue inequality? Yes, it does. So it satisfies one inequality, but not both of them, okay? Now flip down to this bottom red triangle. Does this satisfy the red inequality? Yes. Does it satisfy the blue inequality? No, because it's not shaded blue. So again, this section right here satisfies one inequality, but not both. So both of these sections, the top blue triangle and the bottom red triangle, they both satisfy one inequality, but not both. Are those solutions to the system? What has to be true for them to be solutions to the system? They have to satisfy both, right? So those are solutions to individual inequalities, but those are not solutions to the system. The section right here, okay? This section right here that is both shaded red and blue is what satisfies both inequalities. Okay? So this section right here is what satisfies both inequalities. So these ordered pairs that lie within this double shaded region are the ordered pairs that would satisfy this system, right? So in order to be a solution to the system, it has to satisfy both inequalities in the system. Okay? Any questions? Okay, so let's consolidate this and let's practice a little bit. Okay? So go to the back page. Second page. What's on the third? Alright, so let's look at 1 and 2. Let's do 1 together and then I'll let you guys do 2. So I want to know, it says in exercises 1 through, well, that's the wrong number, sorry. In exercises just 1 and 2, tell whether the ordered pair is a solution to the system. Okay, in order to be a solution to this system, that ordered pair has to satisfy both inequalities. So let's plug it in and see if it satisfies both inequalities, okay? So this top inequality, what is the y value from the ordered pair? What's the y value? Hello? Y value from the ordered pair? 0. So this would be 0 is greater than 2. Is that true?
No.
No, it's not true. So I know this is not a solution. Okay? So it would have to make both of those inequalities true in order to be a solution. So I'll give you guys like 30 seconds. Go ahead and do number 2 together with your groups. Okay, so if I'm testing on number 2, what is the y value from the ordered pair? 1. So 1 is less than 3. Is that true? That one's good. Let's check the second one because remember it has to be a solution of both. Okay, so y is 1. Put down my greater than sign. X is negative 1 minus 4. So negative 1 minus 4 is negative 5. So is 1 greater than negative 5? Yes, so that one works too. So since I got 2 check marks, I would say yes. It is a solution. Okay? So yes, it is a solution. Okay? So if I'm testing if an ordered pair is a solution, it has to make both inequalities true. Now let's look at the big question. Okay? If I can graph these. Okay? So let's look at 3 together in our groups. Or sorry, let's look at 3 just together. Okay? So I have a special case line for the first one, right? Because I have a y but no x. Okay? So I'm going to teach you how to do this with one color. Because think about it, when you're taking assessments, you're not going to have colored pencils with you. Okay? When you're taking like I-STEP and stuff like that, you're not going to have colored pencils. So you need to know how to do this with one color. So I'm going to try to teach you how to do that. So this one's going to look a little bit different than the first one that we did when we used 2 different colors, okay? All right, so let's do this all in one color. So let's try the first inequality first. So it says y is greater than negative 2. So that's a special case line. So everybody show me the y-axis with your arm. Now show me a y equals line with your arm. Good. So it's opposite the axis. So I'm going to go down 2 on the y-axis. That's where it's going to cross. Is it going to be a dotted line, a dotted horizontal line, or a solid horizontal line? This one's going to be dotted, right? So I'm going to do my dotted or dashed line. Okay, and then this is where we're going to stray from the first problem that we did, okay? This is what I'm going to suggest to you. For this first inequality, does the inequality sign tell us to shade above or below? Above, right? So instead of actually shading, this is what we're going to do. I'm just going to go from this line and I'm going to draw little up arrows. See my little up arrows? So that's telling me eventually when I do shade, I'm going to be shading above that line. Because remember, I'm looking to shade the part of the graph that satisfies both of these inequalities. So right now, this is telling me I'm only looking at this part of the graph now, right? I'm not looking below that graph for solutions because I know nothing down here is a solution. So let's go ahead and do our second one. Remember, we're going to stick with the same color. Okay, so let's look at our second one. So so I have an x and a y, so I know it's not a special case line. What is the y-intercept for my second inequality?
3.
So y equals mx plus b. What's the plus b part? 0, right? There's not one there. So my y-intercept is going to be 0 right at the origin. What's my slope? That's the 3, right? So it's going to be 3 over 1. So I'm going to go up 1, 2, 3, and over 1. I'm going to go up and off the graph, so down 1, 2, 3, and left 1. And that's how many points I can put. Is this going to be a solid or a dotted line?
Solid.
This one's going to be solid because it's equal to, right? So put your nice solid line on there. Okay? And then should this one be shaded above or below?
Below.
Below, right? Because it's y is less than. So I'm going to go to my line and I'm going to put little down arrows. Okay, so now that we have both sets of arrows on there, let's go ahead and shade. So what is the region that has both arrows pointing towards it? You have to decide, is it going to be this one down here? So is it this one down here? No, because it's pointing up from this line, right? So this would be one but not both. Is it this region right here? No, that doesn't have either one pointing to it. Is it this region right here? No, because this arrow is pointing down, so it's this region right here. You see this region right here is what has both arrows pointing to it. So that's the region you can go ahead and shade. Okay? That's the region that has both inequalities pointing towards it. So that's the region that is shaded. If you see this electronically, it is very possible that you will still see these areas shaded lightly and then the area that is overlapped shaded darker. Okay? So I want you to know what that looks like electronically. But for our sake, when we're doing it on paper, I think this is going to be the best way for us to do it. Okay? All right. So you guys go ahead and try 4, 5, and 6 together with your groups. Okay? 4, 5, and 6 together with your groups. Go ahead. Okay, so y equals line. I'm going to hit the y-axis at 3. Oops, need my pen. There we go. Okay, it's going to be a horizontal line. And it's going to be dotted because it's not equal to. Okay? That says y is less than. So I would be going down from this line. So I'm going to put little down arrows. Okay, now let's do my second line. So it says x is less than 2. So x is 2 is going to be here on the x-axis. It's going to be horizontal. It's going to be dotted again because it's not equal to. Okay? And then it says x is less. So this is the only time we go left and right. So the lesser x values are to the left. So the part that is double pointed to would be this square right here. Or this box right here. Okay? Questions on 4? Okay, let's look at 5. So top line, the y-intercept is -2. The slope is up 1 over 1. It is a solid line because it is equal to. And it says y is bigger, so I would be shading up above. So I'm going to put my up arrows. The second inequality has a y-intercept of +2 and a slope of -1, so that's down 1 over 1. Okay, it's going to be a dotted line because it's not equal to. And it says y is less, so I'm going down from that line. Okay, the part of the graph that has two sets of arrows pointing to it would be this section right here. Okay? So what that means is any ordered pair in this shaded region would be a solution. So if I wanted to say the ordered pair -1, comma 1, that would be a solution, right? If I wanted to say -4, comma 0, that would be a solution because it's in the shaded region. Okay? All right, and then lastly, number 6. Number 6 is the hardest type because we do not have y by itself. Can I get a show of hands? How many people turned it into slope-intercept form first? And how many people did standard form with intercepts? A whole one person. Okay. All right. So we will do. I'll do slope-intercept form then. Okay. So if I'm getting y by itself up here, I'm going to subtract 2x. So I have 3y is less than 6 minus 2x. Divide by 3 on every piece. And y is less than 2 minus 2/3 x. The other one, add 1 to both sides, it would be y is greater than or equal to -2x plus 1. And we're running out of time, so I'm not going to finish this problem, but you have the other two examples, okay? Oh.